So what are continuity and bounds? Well, continuity is a fairly simple concept, and it's this idea that if I can draw my line and I don't have to lift my pen up, it's continuous. But once I have to lift my pen up, for example, from here to here, okay, this is now what we call discontinuous. Okay, now even if there wasn't that dot there, I would come here and there's a hole there, so I have to jump over that. So I have to kind of lift my pen up, go over it, and then I can continue drawing it. So continuity is this issue of if I can just keep my pen on the paper, it's continuous. Okay, so when we talk about continuity, we have points of discontinuity. So in this case here, this represents a point of discontinuity because at this point here, I have to lift my pencil. At this point here, again, got a big jump, so I have to lift my pencil here. So when we talk about continuity and discontinuity, okay, this is discontinuous at x equals 1 and x equals 2. Okay, those are points of discontinuity. When it talks about bounds, what are the bounds of this function? Okay, the bounds are going to be where it's going to be defined. Okay, so in this case, it's defined from this point 0. Okay, yeah, it's defined at that point. Okay, it's defined at 2. It's defined all the way to 3. So the bounds of this function are going to be from 0 and including 0, so I'm going to show that as a square bracket, all the way to 3, which I'm going to show as a square bracket. Now this is equivalent to saying that's equal to x is equal to 0 and x is equal to 3. So those represent my bounds. Okay, so that's continuity and bounds. Okay, we're going to really look at this much more closely as we get more into the calculus part of this course. Okay, but for now we just want to establish what some of the terminology, continuity, discontinuity, okay, bounds basically are endpoints. So, and when I talk about bounds as well, when we have piecewise functions, we have bounds for each piece of those piecewise functions as well. So we can look at it that way. Okay, moving on to inverse functions. Inverses are switching x and y. Okay, we also can think of inverse as going the opposite way through a function machine. And we could also think of it inverse as undoing any function. So inverse of plus is minus, inverse of times is divide, inverse of square is square root. So here, when I do an inverse, okay, we're going to have some graphical relationships here. So when I'm going to draw some reference points here. So 3, 0, let's go 4 and 1, and 7 and 2, and that's probably good enough for now. So I have my points here. Okay, so I'm going to end up with a square root function that looks like this. When I inverse it, what ends up happening is all my x's become y's. So I end up with 3, 4, 7, and all my y's become x's. Okay, so 0, 1, 2. And what I've done here is I've just switched my x and y. This is an inverse. So right now at this point I've done an inverse. But often we want to see this as y equals. And when we do this as y equals, we solve for the y. And to solve for the y, we undo or inverse these operations. So if I'm going to get y equals, I'm going to square both sides. And I'm going to get rid of the minus 3 with a plus 3. I use the inverse operations. Okay, and when I graph this, I'm going to end up with 0, 3, 1, 4, like that. There's my inverse. And when I draw it on this side, okay, it looks like that. And we end up with a mirror image. Okay, so one of the physical properties of an inverse is that it is a mirror image across that line y equals x. And notice I only drew half the parabola because the inverse of a square root is not exactly a square. It only gives me this half parabola. So I actually have to state the domain of this is going to be from x is greater than or equal to 0. Okay, and my range here would be y is greater than or equal to 3. And notice that if I look at my domain here, the domain was x is greater than 3, greater than or equal to 3, and my range was y is greater than or equal to 0. Notice that not only do my x and y's change, my x and y variables change, my domain and range change. Okay, so that they just switch. Okay, the domain and range just switch when we do an inverse as well. So an inverse property has switching of x and y's. Okay, it is a mirror image across this line, and it also is an inverse operation. So this square root becomes the squared function, or at least half the squared function here. Okay, so those are properties of inverses that we want to connect to each other.